Z-scores. The Z-score associated with a data value measures the number of standard deviations the data value lies above or below the mean. It is positive if the data value is greater than the mean, and negative if the data value is less than the mean. For example, a data value with a z-score of 1.5 lies 1.5 standard deviations above the mean. A data value with a z-score of negative 0.6 lies 0.6 standard deviations below the mean. A formula for calculating z-scores, which is also called standard scores, is given below. So z is equal to x sub I minus mu divided by the standard deviation. So the z-scores are different than the MAD, the variance, and the standard deviation. The MAD, the variance, and the standard deviation is a number we calculate for the whole data unit, the whole data set. A z-score is we calculate using one element of the data, and we compare that to where it is in place of the mean. So when we calculate z-scores, we use data that we call normally distributed. It makes this bell-shaped curve, and the middle number is the mean, and then we go up 1, 2, 3 positive standard deviations, and down 1, 2, 3 negative standard deviations. So measures of the spread of the z-scores. On the number line of the graph below, label the middle by writing the mean of 4. Then, using the size of one standard deviation 2 years as a scale, label the number line as a graph below. 3 standard deviations to the right and 3 to the left. So again, this is our normally distributed data. It makes a bell-shaped curve. The central line here is our mean. In this instance, our mean is 4. Our standard deviation is 2, so we're going to represent 3 standard deviations to the right. So 4 plus 2 is 6, plus 2 is 8, plus 2 is 10. So any data here would be above the mean. We also are going to represent the data 3 standard deviations below the mean. So 4, 2, 0, and a negative 2. So anything on this side would be considered below the mean, and it would have a negative z-score. Above the mean, you'd have a positive z-score. And to be 0, you would be the mean. So how many standard deviations away from the mean is a dog that is 6 years old? Well, the mean is 4, and if he's 6, he's 1 standard deviation above the mean. How many standard deviations away from the mean is a dog that is 10 years old? Well, here's the mean, and we go 1, 2, 3. So he's 3 standard deviations above the mean. 4 years old. He's no standard deviations above the mean. He is the mean. 2 years old. You go to the left 1 standard deviation, so 1 standard deviation below the mean, and we would expect him to have a negative z-score. And how many deviations away from the mean is a dog that is 7 years old? Well, here's 4, and here's 6. 6 is 1 standard deviation. 8 is 2 standard deviations, so 7 is right between there, so he's 1.5 standard deviations above the mean. What you have just found for each of these questions is called a z-score, the number of standard deviations away from the mean. Z is equal to x minus mu divided by the standard deviation. Now find the z-scores for the next 4 dogs. So a dog that's 4.5 years old, so we would take, that's our data point, so 4.5 minus 4 divided by 2 is 0.25, a z-score. So go ahead and calculate the rest of the z-scores. So the first one, for an age of 3, he's negative 0.5 z-score. 2.6 has a negative 0.7 z-score. 0.75 has a negative 1.625. These are all negative z-scores because the mean is 4 and all these numbers are less than 4.